Hi, this is Adolph Oliver, and this video is about using the point slope form of the linear equation to be able to come up with equations and graph and do all kinds of stuff like that. Anyway, here's the idea. Very commonly, when we're given starting information, we may be given a point that's not on the y-axis, which means it's not a y-intercept. It can be somebody out in the middle someplace. So definitely not a y-intercept. Okay, well, that being the case, we can't use the old slope-intercept form of the equation because we don't know what the y-intercept is. But there's a cousin to that, the point-slope form, which we can write like this: y equals, or y minus y1 equals m times x minus x1. Now, the x and the y here, without subscripts, are the regular x's and y's in the equation. The x1 and y1 are the coordinates of the given points. So, for instance, this guy here, we could have x1 and y1. Well, these would be the values we'd plug in for these, and m, of course, is the slope that we're used to. Now, we can also graph equations giving, if we're given the slope and a starting point, like x1, y1. Here's the process. We'll just talk about it generally here. We'll be looking at examples in a little bit. Okay, so x and y. So let's say we got a point, starting point out in the middle someplace, kind of like this guy up here. Well, here's what we simply do now. We say, okay, whatever this m is, remember m equals rise over run. And so we can come up with the run value and the rise value. Remember, the run is the horizontal distance. Okay, this would be the run. And then if the rise happened to be positive, we'd have an arrow going up like this. If the rise was negative, the arrow would go down. And you scale up the distance that it has to go. So this would be the rise. Okay, and at the end of that second point, okay, our second arrow is another point on the line. So simply just take and draw the line. Well, we'll be doing both these processes coming up here. Let's take a look at a starting example where we just want to get the equation and not graph it yet. So here we are. Okay. Now, the first thing, it says write the point slope form of the equation, a line going through the given point with the given slope right here. Well, here's the first thing about this. You see this point? This is not a y-intercept. To be a y-intercept, x would have to be 0. So since this is not 0, okay, then that means it's not a y-intercept. Well, that being the case, we can't use good old y equals mx plus b. We've got to use the point slope form no matter what. So here it is. Y minus y1 equals m times x minus x1. Okay, we're going to substitute values for x1 and y1. So let's rewrite this with some holes so we're ready to do it. Y minus, here's a hole for y1 equals. Now the m is right out in front of the parens here, so you can just write that down as you go by. It's going to be negative 2/3 in this problem. There's our m. And then in parens we have the regular x, but then we want to make a hole for x1. Here it is. Okay, and there's the right parent here. So we got a hole for y1 and a hole for x1. Now, be careful here. Remember, this is x sub 1 and this is y sub 1. The value going out in this first hole is y sub 1, which is negative 1. The value going in the second hole is x sub 1, so this is negative 3. Well, anytime you've got more than one sign in front of a number here, you need to clean it up. And the two minuses here give me a plus. Same thing going on here. Two minuses give me a plus. Now notice they said they wanted the final answer in point-slope form, so we can leave it in this general form, but we do need to do the cleanups we said here. So I have y plus 1 equals negative 2/3 times x plus 3. Okay, there it is. There's our equation given in point-slope form. Again, it goes through the point negative 3, negative 1, and has slope negative 2/3. Okay, well now let's look at another one. Here we go. Okay, and this one. Okay, notice once again, and note they want slope-intercept form here. Now be careful on this, because even though they want slope-intercept form, once again, you see this ordered pair we got here? X is not equal to 0. So since that's the case, this is not a y-intercept. So that means we cannot use y equals mx plus b because we don't know where it crosses the y-axis. So look at what you're given, and that tells you what you have to start with. Okay. If this is not a y-intercept, and it's always easy to tell a y-intercept, you'll always have x equal to 0, then you must start with y minus y1 equals m times x minus x1, no matter what. Okay? Now, once again here, let's set this up to plug our values in. This 4 is going to be my x sub 1. The 1 here is y sub 1, and notice the slope here is negative 1. Okay, well, make the holes. Y minus, here's a hole for y1, okay. Now again, since the m is out in front, we can put it down right now as we go by, so it's negative 1. And then we have x minus, and here's a hole for x1. Remember, the x and y's that don't have the subscripts are the regular x and y in the equation. Okay, carefully get things in the right spot. Remember, this first hole is y1, so y1 is 1. X1 is 4. That goes in the second hole over here. Okay, so cleaning this up, there's only a single sign here. I've got y minus 1 equals negative 1 times x minus 4. Now, this is slope-intercept form, and if that's all they wanted, we could stop right there like we did in the last example. But they want the final answer in slope-intercept form. Well, that's easy to do. You just solve this guy for y equals. So the first thing you do here is take and use the distributive law on the right. The guy on the left remains the same for the moment. Negative 1 times x is negative 1x. Negative 1 times negative 4 is positive 4. Okay, one more step and we've got what we want. So we want to solve this for y equals, so take the minus 1 and jump it over here as plus 1. Okay, that means I've got y equals negative 1x plus 4 plus another 1 will be plus 5. Okay, there is our answer in slope-intercept form, but we had to start up here with point slope because the information we were given to begin with was not a y-intercept. So remember, even if they want slope-intercept form, if this is not a y-intercept, you must start with point slope, turn around and get the point slope equation, then clean it up, solve it for y equals, And this is the slope-intercept form right here. Remember, slope-intercept is y equals mx plus b. We didn't know the b was plus 5 to begin with, so we could not start with this. We had to start with the point slope. Okay. Well, now, let's see what we got in the next one here. Okay. Now, it says in this one, write the slope-intercept form of the equation with a line through the given point with a given slope. But look at this slope. It is undefined. That means that if we were to graph this, it'd be a line going straight up and down. Remember, this is m equals undefined, or infinity if you wanted to write it that way. So we can actually take a shortcut on this, turn around and say, okay, where's my original point they gave? Notice it's not a y-intercept here because x is not 0 again. But let's plot where it is. X equals -1. Okay, and y equals 5. 1, 2, 3, 4, 5 would be up here someplace. So up about here is our initial point. Well, remember, the line is vertical. That's what you have to have when you have an undefined slope here. So that means that if we were to graph this, it would come down straight like this. Well, remember how we get the equation for a line like this? We say, okay, where does it cross the axis here? And it crosses the x-axis at -1. So we'd simply say x equals -1. Now let's double check that, because if you were given x equals -1, you would say, okay, here's the point -1, and you would draw a line perpendicular to the x-axis, because that gives us x equals -1 all along that line. And of course, that's the line that goes through the given point up here too. So, very easy then to come up with what the equation is. Remember, if the slope is vertical, undefined, or horizontal, 0, you're only going to have one of the variables, and the easiest way to see this is just to graph the thing and then say, okay, how would I give the equation for this? Well, x would equal -1. Special cases like that, you always want to look for slope being undefined or slope being 0. Okay, let's see. Right here, write the standard form of the equation of the line going through the given point. Okay, standard form simply means that we have the x and y on the left and whatever the number is over here on the right. So you remember that as standard form. Why we're talking about that is when we start doing systems of equations, this standard form will be the important way we want to use. Now notice once again, you see this x value? X is not equal to 0. So again, this is not a y-intercept, which means we cannot start with y equals mx plus b because we don't know b, which is the y-intercept. Okay, so what we're going to have to use then is the point slope. Anytime you have some point out in the middle someplace. So here it is, y minus y1 equals m times x minus x1. Okay, well, let's get ourselves set. Remember, this is the x1 point and the y1 point, and here's our m right here. So now make the hole so we can substitute in here. Y minus, here's a hole for y1, equals m. Now, since the m is out in front, we can drop it down right now, and it's -3/4. And then we have x minus, and here's a hole for x1. Here it is. So here are the two holes that we have. Now again, be careful. This leading hole here is y1, and y1 happens to be -1 here. And the second whole is x1, and x1 is -4. Okay, well, we got a little cleaning up to do to begin with. Anytime we have more than one sign in front of a number, you've got to clean it up. The two minuses give me a plus, and the same thing right here. So what we've got is y plus 1 equals -3/4 times x plus 4. Okay, well now, what we've got here, okay, is the point slope form, and if that's what they wanted for the answer, we could stop right there. But what they want is the slope, not the slope, they want the standard form. So let's start cleaning this up. We'll distribute the -3/4 in the right. The left will stay the same here. Y plus 1 equals. Now, this will be -3/4 times x, and minus times minus will be minus. Well, remember, I can make a fraction out of this by putting a 1 underneath. The 4's would cross cancel, so this is going to be -3/1, or simply -3. Now, here's something that's normally done when you put the equations in standard form. If there's a fraction in here, you want to clear out the fractions and get rid of them. So notice the LCD here equals 4, the only denominator we have. So what's going to happen then is I'm going to multiply each and every term on both sides by 4. The two terms here and the two terms over here. Okay, now there's only one denominator that we reduce out, this guy right here. Now carefully put the leftovers back together. I got 4 times y plus 4 equals, now remember we canceled out the denominator here, so it's only -3x, and then the full 4 is here, so -3 times 4 is -12. Okay, well, remember, standard form, we want x and y on the left, plain number on the right. So this -3x has to go over this way, and the plus 4 has to come over to the other side. -3x comes over as plus 3x, okay, and my plus 4 comes over as -4. So what do we got here? Well, this is officially a plus 4y here. So I can write this if I want to keep it in alphabetical order. 3x, you can put the plus in front or leave it off, plus 4y, okay, 3x plus 4y equals, what do we got here, -16. Now, this is what we want in standard form, x and y on the left, and the plain number on the right. Now let's go back and look at this from the top again here. Remember, here's the idea. They said they wanted the final answer here in standard form, which means x and y to the left, plain number to the right. We saw that the information given here was a point out in the middle. It was not a y-intercept, so we had to start with the point slope form of the equation, the only thing we can do. So I've got my x1, my y1, and my m. We substituted those all in. Then I distributed the slope, the -3/4 over, and we got this guy right here. Okay, well, of course, we want standard form, so x and y's have to go to the left, but in standard form, they always like it to be given without any fractions. So I noticed we had one fraction here, okay, the only one, so the LCD is 4. You have to multiply every term in both sides, once and only once. The 4's canceled out here. I put the leftovers together on the guys that remained here. And what we ended up with then was, let's see, plus 4y plus 4 equals negative 3x minus 12. Well, the x has to move to the left because we want the x and y's there. The 4 is a plain number, has to move to the right. And so once we did that and cleaned it up, we ended up with 3x plus 4y equals negative 16. Okay, well, standard form then. We've seen cases here where we left the answer as point slope, we left the answer as slope intercept, and this one in standard form. Any one of those three can be requested. Okay, the last thing to talk about here is how do we graph this? And notice now, once again, this is not a y-intercept. X is not equal to 0, so not a y-intercept. Okay, well, we're not going to be using the equation here. That's not what we're after this time. We're after grafting this. So here's what we're going to do. Make our x and y axes here. Here they go. X to the right, y going upstairs. Put down the one and only point we know. X equals negative 3. 1, 2, 3. Y equals negative 2. Here it is right here. So this is my starting point right there. Now, the slope is 5/8. That's positive, so we're going to be going up. So here we go. Remember, m equals rise over run. And, of course, the slope in this particular one is 5/8, so here it is. Our m equals 5/8. We also know that it's rise over run. Well, that allows us to identify who's the rise and who's the run. So we're going to run 8. Both these guys are positive. Now, 1, 2, 3 will get me back here. I'm going to need 5. 1, 2, 3, 4, 5 will be about here. So running to the right here, okay, to get our total run of 8, I had 3 here plus 5 more, so this is the run, which equals 8. Now, at the end of that arrow, we got to put the rise arrow. The rise is also positive. It's 5. I got 2 to get back here, so I need 3 guide marks up here. So at the end of this arrow, I'm going to go up. There's 2, 3, 4, 5, right to this point. So there's the rise equals positive 5. Well, as always, at the end of that second arrow is another point on the graph line. So just get your ruler out and connect the dots. Here we go. There's the graph.